Volatile organic chemicals are an array of chemicals that are used as degreasers to remove grease from metals. Some of the chemicals were perchloroethylene, trichloroethylene, 1,4-dioxane, carbon tetrachloride. These are the volatile organics. They're volatile in nature, that they volatilize and then turn into a gas.
What did you just say? I can't even pronounce those words.
Well, I think we can go through them one by one so we can see what they really are. So the first one is perchloroethylene.
Perchloroethylene?
Yeah, you got it. So we can draw out the chemical structure of it. So perchloroethylene has two central carbon atoms, like this. They're labeled C, and they're double bonded to each other. And they also have 3 chlorine atoms situated around the center, like so. So these are 3 chlorine atoms, and these are bonded to the carbons. So now there are 4 chlorine atoms, which fits with the name perchloroethylene. The next chemical we're talking about, it's called trichloroethylene. There's the same structure as before. There's 2 central carbon atoms, but this time there's 3 chlorine atoms around the center and that 1 hydrogen atom.
So this one has 3 and this one has 4 chlorine?
Yeah, so that's actually why they're named how they're named. So trichloroethylene, tri means 3, so there's 3 chlorines. And perchloroethylene, we sometimes also call it tetrachloroethylene. So tetra means 4. So there's 4 chlorine atoms in tetra and 3 in tri. Okay, so the next molecule that Dan told us about is 1,4-dioxane. So in this molecule, there's actually 4 carbon atoms.
Oh, carbon, like this side.
Yeah, exactly. So, but the difference is in this molecule, there are 4 carbon atoms. This molecule also has oxygen atoms along the center. And finally, each of these carbon atoms have 2 hydrogens bonded to them.
That's a lot of hydrogen. Why is it called 1,4?
So the interesting thing about this molecule is that if you look in the center, there's this ring of 6 atoms. You can kind of label them 1 through 6, so 1, 2, 3, 4, 5, 6. So in 1,4-dioxane, the first atom and the 4th atom, so 1 and 1, 2, 3, 4, these are both oxygen atoms.
Oh, so it's called 1,4 because the oxygen right here is on the top, and then 1, 2, 3, 4 is on the bottom?
So it's the first and 4th one. So we have one more chemical that Dan told us about. It's called carbon tetrachloride.
Can I try drawing this one?
Yeah, so just go ahead and write out its name first. Carbon tetrachloride.
Carbon tetrachloride.
Yeah, so what that means is there's 1 central carbon atom, sort of like these 2, and then the tetrachloride, a lot like this first chemical we looked at, that means there's 4 chlorines around it. So you can try drawing that out.
1 here, and then 1 on the top, 1 on the bottom, and then 2 right here.
Yeah, there's that carbon tetrachloride. Yeah, so these are the 4 volatile organic chemicals that Dan told us about.
So, VOC.
Yeah, exactly.
Wait, what's a VOC again?
For that, you're going to need these.
What does the orange and the perfume have to do with VOCs?
Great question. When you open an orange, there's a sweet aroma that comes out of the orange and into your nose. You can smell it. The same thing happens with the perfume. You can smell a perfume because the molecules inside of it are coming out and volatilizing it into your nose. They're volatile organic compounds. Who wants to try the orange?
Well, I could already smell it from here.
It's volatilizing. Volatile organic chemicals. For this next part, safety first. Let's put on our goggles. Okay, so remember the perfume and the orange? Those were safe, volatile, organic chemicals, but we also have some that are toxic, like 1,4-dioxane.
Like these?
Yeah, exactly. We don't want these VOCs in our noses or the water.
How do they get in the water?
Well, in any industrial manufacturing, there are metal products that need to be cleaned. So, for example, we put our lubricant, we work on the product, and manufacturers use degreasers to clean the metal parts.
Yeah, so these degreasers, they're so dangerous that we can't have them anywhere near us right now.
But unfortunately, it got into our water a long time ago when they were dumped.
How do we get them out of our water?
So there's quite a suite of different contaminants that require different treatment systems to remove these various chemicals from the water in order to make the water potable and safe for drinking water purposes. The water comes into the front of the plant at somewhere around 7,500 gallons per minute. It goes up to the top of these towers that you see. There's four towers. The airflow is split into 4 separate streams. The water is allowed to go up to the top of the tower and cascade back down the tower. Inside the tower, we have round plastic wiffle balls that are open, plastic balls that have openings in it, and it's packed. The tower is packed with these to allow for aeration. When the water comes down into the tower, it breaks up into caplets of water and cascades down through the plastic balls, and there's a concurrent flow of air that comes off the bottom, goes up through the top, and strips the volatile organics off the water, hence air stripping.
Wait, how do those wiffle balls work?
I don't know. That's a great question.
For that, you're going to need these and this. The purpose of the wiffle balls is to split the water into little rivulets.
Like a spray.
Right.
Can we see how it works?
Sure. Go ahead and grab the water. Now imagine this is the tank. Pour the water in. Do you notice how the water splits?
Like a shower.
Yeah. Now imagine a tower packed full of thousands of these.
Like our drawing. Ta-da!
Hey there, water droplets.
Who are you?
Why, I'm the water prospector. I prospect for water, and looks like I found a couple of little water droplets right here. Oh my, look at this drawing. Would you like to know how that air takes out the volatile organic chemicals from that water?
Yeah.
Well, step right up. Now your water droplets, and you're cascading down through those wiffle balls. And then the wind comes whooshing up right through you, and those volatiles are coming out right out from you, and the air carries it out down through the tube into the carbon filters.
Wow, that was fun. Now we're clean water.
Right. By the way, who needs gold? There's water in them thar hills.
Clean water.